With the ability to improve braking control when it counts, it's no wonder that customers are choosing cars equipped with anti-lock brakes in increasing numbers. Hello, and welcome once again to Mastertech. Because more vehicles than ever are being equipped with ABS, it's important you stay up to date on any changes in the anti-lock braking systems that come to your service departments. To do that, in this release, we'll cover the anti-lock braking systems on the Eagle Summitt, Summitt Wagon, and Talon, as well as the Dodge Colt and Stealth. We will also cover the ABS-equipped Plymouth Laser, Colt, and Colt Vista. We'll start with a look at the new anti-lock brake system used on the '93 Colt and Summitt. If you review the materials from the February '92 Mastertech or the December '91 Videotech, you will get a clear picture of basic MMC anti-lock brake operation. Since then, however, there has been a change. The new 4-channel anti-lock brake system on the '93 Colt and Summitt. Let's take a look at this system's components and operation. As with the other MMC anti-lock systems that you've seen, this system has a wheel speed sensor at each wheel. The wheel speed sensors work along with a toothed tone wheel to send electrical pulses to the ABS controller. These signals tell the controller how fast the wheels are turning. On the Colt and Summitt, the ABS controller is located under the instrument panel behind the floor console. The ABS power relay, which supplies power to the ABS controller, is located behind the lower instrument panel to the left of the steering column. Besides the input from the wheel speed sensors, the other informational inputs to the controller come from the stoplight switch and the generator L terminal. The stoplight switch above the brake pedal informs the controller when the brakes are applied. The generator L terminal signal comes from the generator. It lets the controller know when the engine is running. The outputs from the controller are to the ABS warning light, the data link connector, the ABS valve relay, the solenoid valves in the hydraulic unit, and the ABS motor relay. As you no doubt know, the ABS warning light in the instrument cluster will be triggered by the controller if a problem develops with the anti-lock system. Of course, all diagnostic information contained in the ABS controller can be accessed through the data link connector. The ABS valve relay, which supplies power to the solenoid valves, is located in the engine compartment near the hydraulic unit. The hydraulic unit is mounted on the left inner fender in the engine compartment. It contains a solenoid valve for each ABS channel. On the '93 Colt Summitt, that means there are 4 valves. The controller can signal a wheel's corresponding valve to either increase pressure or reduce pressure, based on how much brake hydraulic pressure is needed for each wheel to keep it from locking up. During the anti-lock braking process, more hydraulic pressure is required than can be supplied by the power brake booster. To supply the necessary hydraulic pressure for the system, an electrically driven pump is used. The pump and the motor that drives it are both contained in the hydraulic unit. The pump motor assembly is activated by the controller through the ABS motor relay. This relay, like the ABS valve relay, is located near the hydraulic unit. If there is an ABS failure, the ABS controller will interrupt power to the valve relay so that no power is going to the solenoid valves. This is called the fail-safe mode. In the fail-safe mode, ABS will not operate, but full foundation braking is available. Of the Colt Summitt system's 4 channels, the front 2 wheels are completely independent circuits, but both rear wheel circuits are balanced by a select low valve in the hydraulic unit. This valve mechanically equalizes the brake pressure between the rear wheels so that during anti-lock operation, the lower of the pressures applied to the rear wheels is always selected for both wheels. This increases vehicle stability. The valve accomplishes this without fluid from the 2 circuits coming in contact with each other. This maintains the integrity of the dual diagonal brake circuits of the foundation brakes. How does all this come together when it's needed? Let's look at an example. Say you're driving on your way home and another vehicle unexpectedly cuts in front of you. You brake quickly, activating the ABS. Unfortunately, your right rear wheel crosses through a small puddle of water. How does the Colt Summitt system react? Since the front wheels do most of the braking on any car, as you might expect from such intense braking, both wheels are displaying a locking tendency. The ABS controller determines this from the slowing wheel speed sensor signals. The controller then signals the valves for the front wheels to reduce pressure. As soon as the locking tendency is over, pressure is reapplied. Naturally, since both front circuits are independent, these actions will not happen at exactly the same moment. In the meantime, the right rear wheel has little traction in the puddle. The controller notices the wheel speed signals slowing down to the point of locking, so it tells the appropriate valve to release brake pressure. At the same time, the left rear wheel is on dry pavement and displays no locking tendency, so its pressure should increase, but it won't. Why? If you remember back to the system component descriptions, the select low valve equalizes the pressure to the lesser of the two pressures sent to the rear wheels. In this case, the pressure of the right rear wheel is the lesser pressure because it's on wet pavement. During all of this action, the pump motor assembly is pumping the brake fluid to maintain the hydraulic pressure of the system. Of course, this is an oversimplification of the entire process. All this and much more happens in fractions of a second. And yet, despite the short distance, our car was able to stop in time. If the distance was shorter, then the anti-lock system would still have enabled the driver to brake and effectively steer around the obstruction. That's a basic overview of the '93 Colt Summitt anti-lock brake system, and it's a good place to start because the other MMC anti-lock brake systems are similar to it. Now, let's test your memory with a review question. The anti-lock system on the '93 Colt and Summitt has how many hydraulic brake channels? The answer is the system has 4 separate hydraulic channels. The remaining MMC anti-lock brake systems are not only similar to the '93 Colt Summitt system, but some are nearly identical to each other. For instance, the anti-lock brake system used on the front-wheel drive Laser Talon, Colt Vista, Summitt Wagon, and Stealth models are in reality one system. This system, unlike the '93 Colt Summitt 4-channel system, has 3 channels. The rear wheels on this system are controlled by the same solenoid valve in the hydraulic unit. To maintain the dual diagonal braking system and to equalize the pressure between the rear wheels, a plunger valve is used. This valve is similar to the select low valve on the Colt Summitt system we just discussed, except that instead of using the lowest of the 2 rear wheels brake pressure, the plunger valve equalizes both pressures. As with the select low valve on the Colt Summitt system, the dual diagonal braking will not be affected in case of the plunger valve's failure. Virtually the only other difference between these two systems is that this 3-channel system does not have a generator L terminal input to the ABS controller. Do you remember what this input was for? The generator L terminal input on the '93 Colt Summitt system informed the controller whether the engine was running or not. The remaining system may look quite a bit different than the previous 2, but its basic operation is similar. This system is for the all-wheel drive versions of the Laser Talon, Colt Vista, Summitt Wagon, and Stealth. The most obvious difference is that this system is a 2-channel system. The left wheels are one channel and the right wheels are the other. As you may have guessed already, the rear wheels are controlled by a select low valve. Another unique feature of this all-wheel drive system is its use of a G sensor. Since ABS won't activate with the vehicle standing still, the G sensor lets the controller know that the vehicle is still moving, so it can apply the brakes accordingly. The G-sensor is needed on all-wheel drive models since all four wheels are connected by a drive line. And on ice or other slippery surfaces, the wheels can decelerate at very nearly the same rate to the point where they are not turning, causing the ABS controller to think the vehicle has stopped. Despite the differences these two systems have with the Colt Summitt system, the components are quite similar. Their locations do vary from car to car, though. Review the February '92 Mastertech or the December '91 Videotech releases for specific ABS component locations on all but the '93 Colt Summitt models. You can see that despite some differences in these systems, the basic operation is very similar. After this review question, we'll take a look at how this ABS operation can be misunderstood by customers. The anti-lock brake system on MMC all-wheel drive models has how many hydraulic channels? The answer is 2 channels. Every MMC all-wheel drive model with ABS has a 2-channel system. With the quick growth in vehicles equipped with anti-lock brakes, many customers will be driving ABS-equipped cars for their first time. While you may know much about how anti-lock systems operate, the new customer may have no idea what to expect. The fact is, many new car customers don't thoroughly read their owner's manual, so it should come as no surprise that they come to the service department complaining of strange vibrations and noises. In such cases, the patience of technicians and service advisors can go a long way to putting customers' minds at ease. Let's review some of the operating characteristics of the MMC anti-lock braking systems. First, the ABS warning light will stay on for about a second after starting the vehicle. If the light stays on after this, then there is a problem with the system, and ABS is not available. In such a case, stress to your customers that at this point, the car is as safe as any non-ABS vehicle, since full foundation brakes are still available. However, if the foundation brake light comes on, advise them not to drive the vehicle. If the ABS warning light comes on while driving, inform the customer to pull over and turn off the engine as soon as it is convenient to do so. They should then restart the car and drive at speeds of 6 miles per hour or higher for at least 20 seconds. If the light goes out, the system is fine. Driving at this speed allows the ABS to go through its self-check procedure that occurs after startup. If the ABS warning light stays on, the customer should be advised to bring the car in for service. The one operating characteristic of the anti-lock system that causes the most concern among owners not used to ABS-equipped cars is the self-check procedure we just referred to. On MMC anti-lock systems, the check is actually performed at about 4 miles per hour. The ABS controller operates the components of the system to check if they are working properly. A whining noise and vibration may be noticed when the pump motor and solenoid valves are activated. Assure customers that this is entirely normal. If they were to lightly apply the brakes during this self-check operation, a slight pedal pulsation may be felt as well. The self-check draws a large amount of electrical power. As a result, the engine in an ABS-equipped MMC car with a completely discharged battery that has just been jump-started may misfire. To prevent this from happening, either fully charge a discharged battery before starting the car or, on the '93 Colt Summitt, disable the system by removing the fusible link for the ABS circuit. It's secured to the battery's positive terminal by 2 bolts. Once the car is started, the ABS warning light will come on as long as the fusible link is disconnected. The fusible link can be reinstalled once the battery has sufficiently charged. With the fusible link installed, start the car again to check that the ABS warning light goes out. This procedure is similar for all ABS-equipped MMC vehicles, the only difference being which component is disconnected. The February '92 Mastertech and the December '91 Videotech discuss the procedure for all MMC models except the Colt Summitt we just covered. If customers noticed the vibration and noise during the ABS self-check, then they may very well notice it during an ABS stop. Some vibration will be felt in the car body, steering wheel, and brake pedal. In addition, the pedal will drop somewhat and then feel hard, as an increasing amount of brake fluid is drawn from the reservoir. Some customers may be unaware of when ABS is supposed to operate. They may mistake ABS operation for a problem in the brake system. For instance, during normal braking on a rough road, the driver may notice the pedal drop and then turn hard. The vehicle also comes to a stop much quicker than the driver anticipated. Since this isn't a panic stop, the customer is unaware that the ABS was activated. In such cases, remind the customer that this just shows the ABS is working properly. One of the great advantages of ABS is that while fully applying the brakes, you still have steering control of the vehicle, so you can avoid the danger. You may need to advise customers that even though you have full directional control, the steering wheel will feel different than during normal driving because the front wheels are likely receiving different amounts of brake pressure. Now, let's take time out for our third review question. At about 4 miles an hour, what causes a notable vibration in ABS-equipped MMC vehicles? The answer is the ABS self-check operation. The vibration comes from the solenoid valves and pump motor being tested. For those of you used to working on domestic anti-lock systems, you probably have noticed some differences compared to the MMC systems. For instance, unlike some domestic systems, you don't have to release brake pressure before performing service, since there is no high-pressure accumulator. The biggest difference, though, is in the area of diagnostics. Unlike the domestic vehicles, there is no separate diagnostic manual. All the ABS-related diagnostic information is located in the regular service manual. When you need to use the scan tool to diagnose any problem, not just an ABS problem, make sure that you follow the proper hookup procedure. First, make sure the ignition is off. If you hook up the scan tool with the ignition on, or if you disconnect it with the ignition on, a trouble code for a failed ABS controller can be registered regardless of the system being investigated. After you've properly connected the scan tool and adapter, then turn on the ignition. When you've finished, turn off the ignition and then disconnect the scan tool. Another important item to remember is to clear all trouble codes from the controller's memory. If this is not done, the ABS warning light will stay on, giving the impression of a failed ABS controller. Always check that the codes are cleared before you assume the controller is faulty. If the codes can be erased, it means the problem was temporary, perhaps intermittent, or happens only when driving. If it is not possible to clear the trouble code from the controller's memory, then that means the trouble is currently being detected by the controller. For instance, trouble codes cannot be cleared when the ABS is in the fail-safe mode. Remember that this is when the system is not operating properly and is then shut down by the controller. If you cannot clear the codes, the trouble will have to be repaired following the steps in the anti-lock braking system troubleshooting section of the service manual. If you can clear the code and you believe the problem to be intermittent, try to duplicate the cause. Usually, intermittent problems are caused by vibration, heat, or excess electrical resistance. Wheel speed sensors are especially vulnerable to vibration from the movement of suspension components. To duplicate a vibration, gently shake or rock the suspect component and see if a trouble code is registered. To test for a malfunction due to heat, use a hairdryer to heat the component. Be careful not to heat the part above 176 degrees or it could be damaged. If electrical interference is suspected, turn on all electrical switches and see if the problem reoccurs. Additionally, check that electromagnetic or radio frequency interference from cellular phones or two-way radios is not interfering with the ABS. The customer should also be questioned if the interference happens in one location. This could be caused by such things as TV stations or radar from airports. Of course, intermittent problems can be caused by a bad connection. Inspect electrical connectors and terminals to ensure that the terminals are clean and their connections are complete. Another important diagnostic point deals with the scan tool. If you have used the scan tool on these MMC vehicles, then you will have noticed that the time before readouts appear on the screen can be longer than with the domestic systems. This is normal and does not indicate problems in the system. The MMC system simply has a slower baud rate, which is the unit used to measure the quickness of communication. As for the readouts themselves, they are identical on all Stealth, Laser Talon, and Colt Vista Summitt wagon models. There are 12 trouble codes on these models. On the new Colt Summitt models, however, there are 27 codes, many of them with different numbers than on the other cars. Keep this in mind in case you have the codes for the other cars memorized. There are also differences in the actuator tests that can be performed with the scan tool. In addition to the solenoid valve tests on previous models, the newer Colt Summitt system has tests for the valve relay and ABS warning light, as well as the test for the motor relay. The Colt Summitt system also allows you to check wheel speed sensor signals, ABS controller voltage, the generator L terminal voltage, and the on-off status of the stoplight switch. The systems on the other MMC vehicles do not have this ability. Regardless of which system you have to diagnose, using the scan tool and the diagnostic flowcharts in the service manual will help you quickly find the cause of any ABS problem. After the review question, we'll use the diagnostic flowcharts to solve a sample problem. If you disconnect the scan tool before turning off the ignition, what kind of trouble code will be triggered? The answer is a trouble code for a failed ABS controller will be triggered. Always turn off the ignition before connecting or disconnecting the scan tool. A customer brings in a '93 Summitt with an ABS warning light that stays on after the vehicle is started. The customer tells the service writer that the problem developed shortly after the vehicle became severely stuck on a muddy, rough road. When the job gets to the technician, he looks up the general ABS troubleshooting flowchart, since an illuminated ABS warning light could signify just about any ABS component. The first step in the procedure is to gather information from the customer. This has already been done, so the technician moves on to the next step, which is to check trouble symptoms. The ABS warning light stays on after the car is started, just like the customer said. The next step in the flowchart is to check for trouble codes with the scan tool. Remember that the scan tool should be hooked up with the ignition off. The technician finds the trouble code 23 for the right rear wheel speed sensor was in the controller's memory. At this point, you should write down the information so that the trouble code can be cleared. Now that the technician has a trouble code, he can refer to the more specific trouble code flowcharts. The comment at the top of the flowchart says that this code is displayed when wheel speed reaches at least 6 miles per hour. But no wheel speed pulses are input, and yet the controller can't verify that the circuit is open. The first step of this chart refers the technician to the procedure for the proper installation of the wheel speed sensor. Everything looks correctly installed, but this procedure also requires checking the air gap between the sensor and the tone wheel. To check the gap, a blade-type brass feeler gauge is recommended, since it will not be affected by the magnet in the sensor's pole piece. The service manual states that the gap should be between 12 thousandths and 35 thousandths of an inch. This gap appears to be a very small amount over 35 thousandths of an inch. Since the gap is so close to being out of range, this could account for the trouble code. Perhaps the gap got knocked out of adjustment when the car got stuck. The technician readjusts the air gap to well within the specifications and takes the car on a road test to see if the trouble code and the warning light reappear. Unfortunately, both do. Apparently, the air gap was not the problem. After again clearing the trouble code, the technician goes back to the flow chart. The next step is to check the wheel speed sensor output voltage. This must be done with the vehicle on the hoist, the wheel off, and the parking brake released. The right rear wheel speed sensor connection to the controller has to be probed at terminals 37 and 45 by either an oscilloscope or a digital volt-ohm meter. Make sure that when you probe this or any connector, you do it from the harness side. Probing the terminals can spread the terminals out, resulting in a bad connection. With the volt-ohm meter hooked up and in view, turn the wheel at approximately 1/2 to 1 full rotation every second. Check the voltage while doing this. Here, we're supposed to get an output of at least 70 millivolts, but we're getting much less. It looks as though the sensor is faulty. To make sure, the flow chart refers us to a test for wheel speed sensor continuity. After removing the sensor, the resistance is measured across the terminals. We get a resistance reading that is much higher than the 1.4 to 2.2 kiloohms listed in the service manual. It's obvious that a new wheel speed sensor is in order. Perhaps the old one got damaged when the car was severely stuck on that rough road. After the new sensor is installed and the air gap checked, the technician takes the car for another ride. The ABS warning light is no longer on, and a check with the scan tool reveals that no trouble code has been registered. Not every diagnosis and repair goes this easily, but following the proper procedures in the manual will help you find the answer to your diagnostic problems in the minimum amount of time. Now, let's see how much time it takes you to solve this problem. When probing an electrical connector, should the probe be inserted in the front or in the harness side? The answer is that, when possible, you should always back probe a connector to prevent spreading out the terminals, which could lead to poor contact. Well, that's it for this month. We've looked at the 4-channel system on the '93 Colt and Summitt and compared it to the other MMC Antilock systems. We've also reviewed the operating characteristics of the MMC systems, as well as informing you about their diagnostics and using this information to tackle a sample problem. Between this program and the previous Antilock releases, you should have a very comprehensive understanding of how these MMC Antilock braking systems work. We hope it'll make your job a little easier. Until next month, goodbye.
As part of a continuing program to supplement your training, this videotape was developed by Chrysler's Service Training Group to provide an overview of the different types of fuel tubes, hoses, clamps, and quick connect fittings you will encounter during the service of fuel systems on both passenger cars and trucks. It's important to note that the procedures illustrated in this program apply to fuel system components and fittings for gasoline-powered vehicles only. The procedures do not apply to diesel and alternate fuel vehicles. Also, the procedures illustrated do not apply to air conditioning lines, transmission cooling lines, and other hydraulic lines, even though some of the fittings and lines in these systems may be similar in appearance. Always refer to the appropriate service manual procedures for repair and service of these systems. This program was designed with 2 main objectives in mind. 1, to familiarize you with the proper service procedures you must be aware of when working on any fuel system component. 2, to review the different types of quick connect fittings currently in use on both passenger cars and trucks. Before beginning service on any fuel system related problem, always consult the proper service manual to familiarize yourself with the system being serviced. Also, observe all of the safety precautions and warnings in the manuals related to the procedures being performed. If diagnostic system tests are required, follow the manual procedures exactly as they are written to ensure an accurate and safe test procedure. While working on a fuel system condition, proper safety precautions should be followed, such as posting no smoking and/or fuel system warning signs around your work area to warn others. Careful, thorough service of fuel systems is critical for proper vehicle operation and customer satisfaction. To ensure service quality, it's a good practice to carefully inspect all fuel system components, lines, and connections while the vehicle is being serviced. During the inspection process, you should check all fittings, couplings, and clamps for fuel leaks, and check all hoses and fuel tubes for signs of wear or damage. It's important to remember that the fuel system is under pressure, even with the engine off. Before servicing any fuel system hoses, fittings, or tubes, the fuel system pressure must be released. To do this, first disconnect the negative cable from the battery. Next, remove the fuel filler cap. If the vehicle is equipped with a fuel pressure test port on the fuel rail, remove the protective cap from the port. Check the service manual for the proper tool number for the fuel pressure test hose for the vehicle being serviced. Place the open end of the test hose into an approved gasoline container. Next, connect the other end of the test hose to the fuel pressure test port on the fuel rail. After connecting the hose, fuel pressure will bleed off through the hose into the container. This procedure may vary slightly from one model to another. Always check the appropriate service manual before performing the fuel system pressure release procedure. You should also be aware that vehicles with 2.2-liter, 2.5 TBI, and 3-liter MPI engines do not have a fuel pressure test port. Always follow the procedures in the appropriate service manuals when performing a fuel system pressure release procedure on these vehicles. The next part of this program will cover fuel tubes, hoses, and clamps. During fuel system service, you will encounter a variety of fuel tubes and hoses. These hoses, tubes, and their clamps, couplings, and fittings should be replaced immediately if there are any signs of leaks or any evidence of degradation. You should never attempt to repair a fuel tube, and never try to interchange one style of tube or hose with another. If replacement is required, refer to the applicable parts catalog for proper part numbers, and always use original equipment parts. Before disconnecting any fuel tube or fitting, thoroughly clean the fittings to prevent fuel system contamination during removal. After disconnect or removal of fuel tubes and components, always cap or cover the ends of fuel tubes and the open ports on fuel system components to protect against fuel system contamination. When storing or working on system components, always ensure that the work area is clean and free of possible contaminants. When servicing fuel system tubes and components, handle the components with care during removal and installation to avoid any damage. During installation, avoid contact of any fuel tubes and hoses with other vehicle components that could cause abrasions or scuffing. Also, be sure that tubes and hoses are properly routed to prevent pinching or contact with heat sources. Ensure that the tubes are properly secured in their original routing clamps or brackets. The tubes and hoses used on fuel-injected vehicles are of a special construction. This is due to the higher fuel pressure. If it's necessary to replace the components, use only original equipment replacement parts. When replacing fuel system clamps, use the proper size original equipment clamps only and refer to the applicable service manual for the proper procedures for installation of these clamps. In some applications, hoses are of a two-piece construction. these hoses will normally have a crimped end fitting. Never attempt to repair a hose with this type of fitting. Some fuel system hoses may have a rigid inner core. Be careful not to bend these hoses. The rigid inner core could be pinched and restrict fuel flow. Also, never replace this type of hose with a standard rubber hose and hose clamp. The next part of this program will cover quick connect fittings found on fuel system components. A wide variety of configurations and sizes of quick connect fittings can be found on both truck and passenger car fuel systems. These fittings can be of either a plastic or metal composition depending on the application for the fitting. These quick connect fittings consist of the O-rings, retainer, casing, and release mechanism. When the fuel tube enters the fitting, the retainer locks the shoulder of the nipple in place and the O-rings seal the tube. There are some important points to remember when working on quick connect fittings. 1. Quick connect fittings are not serviced separately. Never attempt to repair damaged quick connect fittings or fuel tubes. Replace the complete fuel tube quick connect fitting assembly if it's damaged. 2. Never attempt to mismatch quick connect fittings. Mismatched fittings, even of the same size, may appear to connect, but a proper seal may not be obtained. 3. Replace quick connect fittings and fuel tube assemblies with original equipment parts that match the size, design, and configuration that were removed. 4. Before disconnecting fuel tubes, mark or tag the tubes to ensure proper routing and later reassembly. Marking tubes is particularly important when disconnecting multiple tubes in the same area or when working on vehicles with a fuel return system to ensure that fuel feed and return lines are not reversed during assembly. Even though there are a wide variety of sizes and configurations of quick connect fittings, there are 3 basic styles of quick connect release mechanisms that you should be aware of. These are the release ring fitting, the 2-tab fitting, and the single pull tab fitting. Depending on the application, you may find one or more of these 3 styles on any model car or truck. It's important to follow the proper procedures for disconnecting and connecting each of the 3 styles to avoid damage to the connector and to ensure proper sealing. Again, before disconnecting any quick connect fitting, perform the fuel pressure release procedure demonstrated earlier. After releasing the fuel pressure, clean the fitting before disassembly to prevent contaminants from entering the fuel tube. The first style of quick connect fitting we'll cover is a release ring type as seen here. This type of fitting can be identified by a full round plastic release ring. 2 types of release rings are being used. One type with a shoulder as shown here and a second type without a shoulder. Some release ring type fittings can be removed by hand without the use of tools. To disconnect this type of fitting, firmly push the fitting toward the component being serviced while pushing the plastic release ring squarely into the fitting. With the plastic ring depressed, pull the fitting from the component. Be aware, if the release ring is cocked during removal, it may be difficult to disconnect the fitting. In the event the fitting is tight, an open-end wrench can be used to aid in disconnecting the fitting, as shown in this second example on the vehicle. Before connecting a release ring fitting, clean and lightly lubricate the fitting ends with clean 30-weight engine oil. Ensure that the release ring moves freely and is not in the release position. If the release ring is frozen in the release position, replace the fitting and tube assembly. Next, insert the quick connect fitting into the end of the component being serviced until it clicks in place. Do not rely on an audible click to confirm that a secure connection has been made. Verify a locked condition by firmly pulling on the fuel tube and fitting several times. As an aid to disconnecting both types of release ring fittings, special tools have been developed. These tools can aid in disconnecting, connecting, and verifying the connection of release ring fittings, especially in tight spots like the fuel rail connections on trucks and LH model passenger cars. To use the special tool, firmly push the fitting toward the component being serviced and position the V-groove of the tool on the top of the release ring and depress the ring with the tool. With the ring squarely depressed, pull the fitting from the component. The tool can also be used as an aid to connect the release ring fitting. To do this, start the fitting on the nipple by hand. Then place the V-groove of the tool below the largest diameter of the Quick Connect fitting and pull the tool toward the fuel tube nipple until the fitting clicks into place. To check the connection, place the V-groove of the tool between the release ring shoulder and the top of the Quick Connect casing and push on the tool a few times to ensure a good connection has been made. A straight variation of the tool is also available for use on fuel rail connections on passenger cars. The second type of fitting you might encounter is the 2-tab Quick Connect fitting, as shown in these examples. To disconnect this type of fitting, squeeze the plastic retainer tabs against the sides of the fitting with your fingers. Do not use tools on this type of fitting. They may damage the fitting. After depressing the tabs, pull the fitting from the fuel system component being serviced. As seen here, the 2-tab retainer will remain on the component after the fitting is disconnected. The O-rings and spacer will remain in the Quick Connect fitting connector body. Again, inspect the Quick Connect fitting for signs of damage. If the 2-tab retainer must be removed, carefully spread the tabs with a small screwdriver and remove the retainer from the component. After removing the retainer, inspect it for any cracks or signs of damage. Again, before connecting the fitting, clean and lubricate the parts. Then insert the Quick Connect fitting into the component being serviced until the plastic retainer clicks into place. Again, do not rely on an audible click to confirm that a secure connection has been made. Verify a locked condition by firmly pulling on the fuel tube and fitting several times. Finally, for the single pull tab style of fitting, press the release tab on the side of the fitting to release the tab. While pressing the release tab, use a screwdriver to pry up the pull tab. After removing the pull tab, the Quick Connect fitting can be removed from the fuel system component being serviced. Inspect the Quick Connect fitting body and fuel system component for signs of damage. If damage is present, replace the fitting and fuel tube. To connect a pull tab fitting, first clean the parts and lubricate them with clean engine oil. Next, insert the Quick Connect fitting into the fuel tube or fuel system component until the built-on shoulder of the fuel tube or component rests against the back of the fitting. Now, obtain a new pull tab and install the tab until it locks in place. Next, firmly pull on the fuel tube and fitting to verify a fully locked condition. After completing service on the fuel system, follow the appropriate service or diagnostic manual procedures to pressurize the fuel system. After pressurizing the fuel system, thoroughly inspect all connections and fittings for any signs of leaks. This completes our overview of fuel system tubes, hoses, clamps, and Quick Connect fittings. Remember that this program was designed to familiarize you with the various types of fuel system components you might encounter on Chrysler gasoline-powered vehicles. For specific fuel system service applications, always refer to the applicable service manuals and parts catalogs for the vehicle being serviced.